Okay guys, welcome back to Estimating Large Numbers. This is the second installment, and we're going to be talking about the counting principle in estimation. The basic counting principle says that when there are m ways to do one thing and n ways to do another, to do both, it's m times n. So a quick couple of examples. Suppose you have 3 shirts and 4 pants, and you want to know how many outfits you could make. Well, that's 3 times 4. It's 12 outfits. Same basic idea, 6 flavors of ice cream and 3 different cones. If you just got 1 scoop of ice cream and picked a cone, there could be 8 different possible ice cream 1 scoop orders that you could create. And then if it's a little more complicated, if there's 2 types of car, let's say a sedan or hatchback, and each of those cars had 5 different colors that they came in, and that they either had a standard model, sports model, or luxury model, then it's the counting principle. 2 times 5 times 3 is a total of 30 possible cars. So we take telephone numbers. During the past few years, there have been several statements of the form, "It is conceivable that we may run out of area codes and telephone numbers within the next 10 years. The shortage of phone numbers is due to the proliferating use of cell phones, pagers, and fax machines." So in the next few problems, we'll see if we can estimate the possible telephone numbers in North America. Telephone number in the form NYZ ABCXXX has 3 sections: the area code, the exchange code, and the station code. Before 1995, all area codes of the form NYZ had some restrictions. We'll go through these restrictions and see that N was any digit from 2 to 9. Y could be either the number 0 or number 1, and Z was 1 to 9 if Y was 0, or Z was 2 to 9 if Y was 1. The restrictions on N say 0 for call operator and 1 for long distance calls. In addition, codes such as 800 and 911 were and still are used for special purposes. In my opinion, this is just extra information. Information that right now you don't need, because it only gave you a couple of examples, but it didn't give you a rule for how those examples came to be. So it's just a little bit extra information. We don't necessarily need it right now. So what we want to see is how many area codes were possible before 1995. So if we take the area codes NYZ, we'll do this twice, because Y can only be 2 numbers, and Y makes Z change. So if Y equals 0, that's our first number that Y could be, and that's our first restriction on Z. Well, N is 2 to 9, which is 8 possible digits. And Y is 0, so that's only 1 digit. The number 0 is just a single digit. And then if Y is 0, then Z is 1 to 9, which is 9 possible numbers. So if we'd use the counting principle, 8 times 1 times 9 is 72 possible area codes if Y equals 0. Well, then we have this restriction: if Y is equal to 1, then Z is 2 to 9. Well, N is 2 to 9, that's 8 digits. The number 1 is just 1 digit for Y, and Z is 2 to 9 also, so that's another 8. 8 times 1 times 8 is 64 digits. So if we were to add these 2 numbers, we would get that there were a total of 136 possible area codes before 1995. So let's take a look at the post-1995 rules. The restrictions that Y equals 0 or 1 was removed in 1995 because all possible area codes had been assigned. Today, N equals 2 to 9, Y equals 0 to 8, and Z is 0 to 9. The exception to these rules, guys, the exception to these rules are codes that are of the form 37Z and 96Z, which are being reserved for future use. Area codes where Y equals Z are easily recognizable codes and often assigned to special services such as 800 and 877, etc. So now we actually have a rule that governs the 800 numbers and the 911 type numbers. So let's see how many area codes are possible today with these new rules. So let's take the NYZ and figure out how many possible codes there are. Well, N is 2 to 9. Well, again, that's 8 digits. Times how many digits could Y be? Well, Y is 0 to 8. If we were to count 0 to 8 on our fingers, that would be 9 digits. And then Z is 0 to 9. That's 10 digits. Well, 8 times 9 times 10 is 720. If we were to take some of these area codes away, like these 37Z and 96Z, because they're not available right now. Now, that's all up to your reasoning. They are possible area codes after 1995. They're just not open to use yet. So, 37Z, that's one number for N and one number for Y, and 10 possible digits for Z. And that occurs 2 times. Because 37 occurs once and 96 occurs once. So we would subtract 20 numbers from 720 to get 700 possible area codes. You could also subtract however many digits the 800 and the 877 are, but that requires quite a bit of reasoning, quite a bit of assumptions. Those numbers are possible area codes, so again, it's up to your interpretation. Are they possible for anybody, or are they possible for just business? What does it mean by possible today? So let's use the 700 just to make our multiplication a little bit easier as we go on. Now let's take a look at the 7-digit numbers of the form ABCXXX, where X, B, and C can be any digit from 0 to 9, and A is restricted to 2 to 9. There's 2 other restrictions. Guys, restrictions. These mean you cannot have these numbers. B and C cannot both equal 1, since these values are designated for other purposes, such as 911, 411, so on. And 555-0100 through 555-0199 are reserved for fictional uses, such as in television shows or movies. According to these conditions, how many 7-digit numbers are possible in a single area code? Well, let's take our 7-digit number ABC XXXX and see how many possibilities there are for each position. So A is 2 to 9, that's 8 digits. We've done that several times. B, C, and X are all 0 to 9. And guys, that is 10 digits. So what we will do is multiply 8 times 10 times 10 times 10 times 10, and we'll do that 10 6 times. And hopefully y'all know this is the same as 8 times 10 to the 6th power, which is 8 million. Guys, now it's time to look at the restrictions. It says B and C cannot both equal 1, since these values are designated for other purposes such as 911 and 411. Well, if B and C are both equal to 1, then that means B and C are restricted to only 1 digit. But we have A is still 8 digits and XXXX are all still 10 digits. So we have to multiply these. And these restrictions are going to be 8 times 10 to the 4th power, which I believe is 80,000. And then 555-0100 to 555-0199. Guys, that is 100 numbers. So we have to take an additional 100 numbers that we're going to subtract. That's 80,100 that we're going to subtract from our restrictions. So when we take our 8 million that we got before the restrictions and subtract 80,100 because of our restrictions, we'll get 7,919,900 7-digit numbers in any one area code. So when we take the number of 3-digit area codes and 7-digit numbers in any one area code, the counting principle says we need to multiply those. So that's 700 times 7,919,900, which gives you a grand total of 5,543,930,000 possible telephone numbers in the United States after 1995. Well, guys, that's estimating large numbers using the counting principle. I hope you've enjoyed both installments of estimating large numbers.